Thank you very much. Can you hear me? Yes. Thank you very much for having me here in this OpenInfra Day. So, just to get started, So I am here just to share what are our challenges in the laboratory for the upcoming years. And what you can see here is a cloud chamber in which our physicists are evaluating how the cosmic rays affect the formation of the clouds. So, as was mentioned before, I'm the technical leader for the cloud service at Cern. I joined in 2010 in the virtualization area, and I formed part of the team that built the cloud in 2012. And since then, I'm also part of the OpenInfra Foundation. So what we are going to see today is a bit of what we do at Cern, what is kind of the purpose of the Cern cloud, and also what are kind of our visions to empower our physicists to do their job in the upcoming years. So we are the world's largest particle physics laboratory. It has been founded in 1954. We are formed by 23 member states, and we have also Turkey as an associative member of the organization. What we do is fundamental research in particle physics, and in order to do that, what we do is basically collide particles. We use ionized gas that we inject into a series of accelerators. From LINAC, you go to Booster, that's one of our original accelerators, and you go through all the history of accelerators at Cern, from Booster to proton synchrotron to the super proton synchrotron, until you reach the LHC, that is the largest machine on Earth, 27 kilometers. And we collide particles at the speed of light. And from that data that we get from those collisions, we inject it in our data center. So the main goal of the data center that we have and also of the cloud is to analyze the data that comes from the experiments. So we provide an infrastructure as a service that has been in production since 2013, and we are still running the same cloud since 2013, upgrading it in place. We run it based on CentOS 7. We are going to add CentOS Stream 8 as the hypervisor layer technologies, based on a Red Hat OpenStack distribution with our custom patches that we need to embed it into the infrastructure we provide. And all the servers we have are x86. We have a data center in Geneva, in Megan, and then we are adding a new additional one that I will show you later. There's a highly scalable architecture with more than 48 cells across 5 different regions that help us to develop and implement new features on the service. We're running the Stein version, and probably you will be kind of amazed that we're running the Stein version, but it's like we took the decision about splitting the services and running in at different pace. And for example, we have other services that are running on Shina. This is a kind of a picture of the current status of the cloud that we have at Cern. We have almost 500,000 cores deployed to our users. And one of the big transitions we did in the last years was basically move from an environment in which we have around 40,000 VMs to go to physical machines. We host the whole data center there using Ironic, and we provide that to the batch farm that analyzes the collisions from the experiments. So if you look at all the services that we have deployed, it's like we have pretty much a whole set of services provided from OpenStack that you can see above, but we also do have a kind of an underneath layer with all the technologies that you need to use in order to embed this framework and have it integrated at Cern, have it accounted, getting monitoring out of the place, and getting all these integration that's on this side, just to have it working at Cern. It's just that we need to do a bit more to get it fully integrated. So if you look at the future, in the future trends, this is a picture from the Atlas experiment. And if you look at that, it's just this is like an exponential growth of CPU power that they need for the upcoming years. In this second bar is the RAM 4. That is, if you see, it's like we are way above the capacity we can buy for that particular purpose. So the experiments are increasingly, exponentially increasing the throughput that they are sending to the DC, and also the CPU resources that they need in order to process the data they are getting. Moreover, they are also increasing the use of heterogeneous computing. So you are getting from the hardware filters they run on the high-level trigger farms, in front of the detectors, from software, FPGAs, and GPUs. And if you add all of that into the difficult context we have right now in the situation with the energy crisis, this is a very difficult problem to solve. So what we are doing is actually doing a threefold approach. So we are going to increase capacity, but adding a new data center is 3 times bigger than the one we have in Medan. We need to boost flexibility. We need to provide all those resources in a more efficient manner and manage it with the same number of people. But we also need to do the last mile and improve the performance. We need to include any hardware that we can get our hands on embedded there into the same setup and offer to our users. So the first thing is the new data center in PrivCloud that is currently under construction, going to be delivered by the end of 2023. This gives us 12 megawatts of computing capacity that is going to help us to follow the high luminosity, the LSC, and the next version, that is the high luminosity LSC for the RAM 4. What we are doing here is basically we start from scratch. So we have a green field in which we can do all the kind of knowledge that we were obtaining over the years running the current data center with the assets considered from the start, a control plane fully dedicated for that region that will kind of make this data center be alone with the remaining one. We may change the hypervisor to this layout because the hardware we have is different, and we may introduce from the very beginning software-defined networking. But also, this data center will help us to do disaster recovery. So some of the resources that we are putting on the data center, we will also use for critical IT services. And this is very important for us. If we lose the data center that we have in 513, the whole IT department, the IT services we provide, needs to be still sustained. And we are exposing it as an additional region, completely split it from the existing one. That means that if we lose, again, the 513, we can continue to run as if nothing ever happened. And for that, and to provide the required building blocks for the end users, we are looking at multi-site, we are looking at replication. Those are technologies that Ceph, for example, offers, and reviewing the building blocks so users can build their services on top of those. For the flexibility boost, I just mentioned that we are kind of a bit behind on the Stein release. And this is mainly because we were early adopters of the OpenStack software, and we have a huge investment on Nova Network at that time. And we need to just close that gap and get into the recent version that we have in OpenStack. Currently, we are doing a very big cold migration campaign that will get us out of the Nova Network cells we have and provide us kind of the boost to get into the latest releases, because we need all the latest features of the code that we have there. As I said, we are adding 12 megawatts of computing power, so we need to double down as a team on monitoring, automation, and probing. This is really important to manage these 2 independent regions as a whole and in a consistent manner. And we also need to remove the boundaries. Some of the physical limitations that we have on the network are kind of really tying us to the setup. And for that, we are adding software-defined networking. One thing that we invest quite heavily with anomaly detection is if you have 2,000 nodes in your setup, all configured the same, and you do alarms based on thresholds, you may only find kind of a small amount of issues that you have in the setup. But if you find kind of a node that has a bug or a misconfiguration in the settings, in the BIOS, this is very tricky to find. And for that, we have an anomaly detection algorithm that will flag the nodes that are misbehaving, that are not behaving like the rest of the nodes. This helps us when you have a kind of a huge amount of nodes to manage. But also, we need to validate the user workloads. Means that every time that a user creates a machine, we need to ensure that the whole infrastructure we have on top actually does what it's supposed to do. And one thing that we spent quite some time was to use, for example, OpenStack Rally, that is a benchmarking tool, but we use it in a different way. We use it to analyze every single operation that the user can do on the APIs and focus on the infrastructure issues. For example, if you have an availability zone that is down, you can spot it right away. And you can spot also the action that is like breaking. For the software-defined networking, the model that we have right now is very strict. It means that you can only have a machine on a certain rack on the data center. This limits the live migrations can only happen on certain areas. So this actually ties us to the infrastructure. For that, in the last 2 years, we're evaluating different technologies. We did some test beds with Open Daylight, with Open Contrail, now it's called Tungsten Fabric with OVN. And from those, we offer load balancers as a service to the end users. But it's not only, it's just the first step. We want to go one step further and having a fully fledged SDN deployment. And we are using the new data center as the first exercise of running with virtual networks, with cloud IPs, with all as a service, and provide the maximum flexibility and be closer to an upstream cloud provider. As I said, we also need to improve the performance. So it's like get our hands in every single computing resource that we can put in the serve of our physicists to do their job. So we are adding more and more computing resources, but before we were looking just to one metric, performance per watt. We need to find how many resources we can put in the data center we have. But also it's even more performance per dollar, Performance per watt per dollar is now the new metric we need to follow. We need to also figure out the maximum performance we can get and put it in the data center envelope. We also need to provision this heterogeneous hardware that we're providing, monitor and configure them. And that may trigger changes in the whole stack. One huge investment that we did was with Ironic that allowed us to onboard the hardware we have in the setup, allow us to add ARM into the hardware pool, and has been recently added. And users can start to try to validate their frameworks to see if this is a technology that works for them. We also have a new batch of NVIDIA A100 GPUs that is now currently added into the setup. And that comes a question, how to try to efficiently offer them, because we have many different customers or clients come to us and asking us, how you can, I want to use these new GPUs that you're offering for deep learning, for inference, for analysis, for simulations, for geographical models, for mechanical applications. And it's kind of a difficult problem to solve because all of those use cases have different requirements. Some of them need more memory, some of them need more cores, single precision, double precision. So at the end, we have a kind of 4 different families that we are using. And we're trying to find which is the right one to each of them. We offer also them as a virtual GPUs or a PCI pass-through, depending on the requirements. And we are currently looking at multi-instance graphic cards to chunk these A100s we have into smaller pieces and offer them to customers, or clients in this case. But those are really scarce resources. So we need to provide a way that they are recycled and offered to end users in a timely manner. So then they get access to these resources, and all of our user communities can get them. But what we are missing, and this is why one of the points I want to raise here, is we need the help for the community to have quota management on this part. It's like those are extremely expensive resources, and we don't have a proper way of managing those. So, as the conclusion, there is like quite some challenges ahead of us, at least in the organization. We need to catch up with the community. We need to scale up. We need to provision more hardware, and even it's more different. It's not the kind of burn on a server that you install and that's it. It's much more complicated than that. But we are building the foundation, and we as a community, we just laid out the path. It's just in front of us. We just need to walk through. And as I said, this is a joint effort that we do with the community, and we really need these quotas for dedicated resources. And this won't be possible with the team I'm a member of, which I have the cloud and Linux teams that are with us in here. So thank you very much for being here today. If you want to know more about the Cern IT department, you can access that link. You get more insights of what we do. All the code that we have at Cern is open source and is available in that repo. You can look at that. You may see some of the integration patches we have, but then please get it with a grain of salt, because those are kind of very tied to our infrastructure, but you may want to look at those. And thanks again to my colleagues that were there present, because without their work, I wouldn't be here to show you all the amazing work they do. Thank you.